Okay, problem 3. Part A, y is cosine tangent x. So now we have to use the chain rule. Okay, the y prime is, first part, it's a cosine something, right? It's always from outside to inside. The first function you encounter is cosine something, right? From outside to inside. This is the first function you encounter. So cosine something, the derivative is negative sine something, right? So it's negative sine this whole thing, right? Negative sine tangent x. Okay, then you ignore this cosine, right? Then after you deal with cosine, you can ignore cosine. Then the function left is tangent, right? So the function left is tangent x. The derivative is just second x squared, right? So you times second x squared. So this is a rule. Part B, y is this. Okay, again from outside to inside. From outside to inside, the first function you encounter is something to the power of square root of 7, right? Something to the power of square root of 7. Okay. The derivative is square root of 7, something to the power of square root of 7 minus 1, right? So it's square root of 7 times this whole thing to the power of square root of 7 minus 1. Okay. Then, okay, now after you deal with it, you can ignore this, right? You can ignore this. Then the function left is x plus 1 over x squared's derivative, right? Then x derivative is 1 over x squared. The derivative is minus 3, 1 over x cubed, right? X to the power of negative 2, the derivative, sorry, here it's next, it's x 2, or sorry, it's minus 2, 1 over x cubed. Okay, so you multiply this here, 1 minus 2 over x cubed, right? Together, this product is the derivative of y. Okay. So part C, again, y is 1 over sine, right? X minus sine x. So now, okay, AB, we have only 2 layers. For part C, we have actually 3 layers. So first, so what is y's derivative? Okay. First, the first function from outside to inside you encounter is something 1 over something, right? It's 1 over something. The derivative is, right, it's something to the power of negative 1. The derivative is negative 1 times this thing to the power of negative 2, right? Which is also negative 1 over this thing square. So it's negative 1 over this whole thing square, this whole denominator square. Okay? Then times, so now you ignore this 1 over. The function you have is sine, right? It's sine x minus sine x, right? Sine is something, right? So now when you do this derivative, so again you need to use a chain rule, right? First part, it is what? It is from outside to inside. First function you encounter is sine something, right? So it's sine something's derivative. It's cosine something, right? So you write down here it's cosine something. Right, also here it's cosine something. Okay. X minus cosine something. Okay, then, okay, after you deal with sine, you ignore sine. So now you have x minus sine x, right? This derivative is straightforward. It's 1 minus cosine x, right? So here you times 1 minus cosine x here. You also times 1 minus cosine x here. Okay. So this is your result. Yeah, this is your result. Okay. So after you are very familiar with the chain rule, you don't need to write all these steps. Okay, you can just do it in your mind. You can see there are 3 layers. For each layer, just write it down and then multiply them. You don't have to write these details. Okay, after you're familiar with the chain rule. But in the beginning, if you haven't learned this before, I suggest you write this down, right, step by step, to clear your mind. All right, make sure you don't skip steps or confuse yourself. Okay. Part D. All right, part D is we're going to use a strategy called implicit differentiation. So far it's explicit, right? But here it's implicit because now we have, instead of a function, y equals something, right? So now we no longer have a function y equals some function of x, right? Here it's an equation containing x and y on both sides. You can see the left side contains x and y. The right side also contains x and y. So what do? We can differentiate both sides. We can differentiate both sides in terms of x. So d over dx, left side, equals d over dx, right side. So here remember, x is just x, y, right? This y is a function of x. Right? You don't know the formula, like you don't know y is x squared. No, you don't know the exact formula, but you know y is a function of x. Okay, so when you differentiate this, right, first we have to use a products rule, right? It's x squared's derivative times cosine y. Okay, let me write it another way. X squared's derivative times cosine y, right, plus x squared times cosine y's derivative. Right. And sorry, here I shouldn't write the equations. And plus, okay, these parts derivative, it's right. Let's just write it this way: d over dx sine 2y. Okay. Then the right side derivative, again, it's a products rule, right? So it's d over dx x times y, right, plus, okay, let me put a bracket so it's more clear. Okay, plus x times d over dx y. Okay, then this part, sorry, again, not equations. This part, sorry, there's something wrong with the pen. Okay, so this part, what's the derivative? It's 2x, right? 2x times cosine y. Right, 2x times cosine y plus x squared. What is this part's derivative, right? What is this? So it's, again, you have to use a chain rule because remember, y is a function of x. Right? So first step, it's cosine something, right? The derivative is negative sine something, so times negative sine y. And second step, it's this part, right? You ignore cosine, you have this y. So what is y's derivative? It is, right, it is just, alright, it's just d over dxy. It's just d over dxy, or you can just write it as y's derivative. Okay, so this part seems trivial. And so, okay, so that's why you can't just write it as negative sine y. You have to multiply y prime because this is a derivative of x. It's not a derivative of y. Okay, so let's see the difference. What if it's a derivative of y? Then it's just negative sine y. Right? If it's a derivative of x, it is negative sine y times dy over dx. Okay, so this is the difference. Okay, I have to erase this, right? So it gives the space. But of course, it's a video, so you can go back when you need them. Okay. So this is the left side. Right. Let's finish this. Plus, so sine 2y, the derivative is sine's derivative is cosine. Right. 2y's derivative is 2y prime. Okay. This is the left hand side. Okay. Right. This is the left hand side equals the right hand side. Right hand side d over dx. X it's just 1, right? Times y plus x times, right? dy over dx is just y prime. Okay. So now, remember what is your goal? Your goal is what is y prime. Your goal is what is y prime. So this is the question. So now we have a linear equation. Some parts contains, right? Some parts contain y prime. The other parts doesn't contain y prime. So what do? We move all the parts containing y prime to one side. Right. So we move this like to the left side. Right. We move this to the left side. We move this to the right side. Okay. So what do we get? So it's negative this, right, plus cosine 2y minus x y prime, right, equals, when you move this to the right side, you change the sign, right? It's y minus 2x cosine y. So finally, your y prime, it's this numerator minus this denominator. Okay, I think my answer is same as the answer in the answer sheet. So, all right, this is the first 4 question. Okay, I will do 3A, 3B. I'll split it into 2 different parts. Okay, so that's all for this part.